The lamp of any CD spectrometer produces light in the UV range. UV radiation interacts with oxygen to form ozone, which is not only harmful but also deteriorates optical components. Most importantly, oxygen absorbs high-energy light below 240 nanometers and ozone absorbs below 350 nanometers. Therefore, oxygen interferes with far UV CD measurements and ozone with both far and near UV measurements. To prevent the formation of ozone, oxygen must be displaced from the system by an inert gas. Typically, nitrogen is used for this purpose. There are risks related to the use of nitrogen itself, and users must first familiarize themselves with these risks. Please take a moment to pause the video to read the on-screen safety precautions. The nitrogen should have a purity of 99.998%, which corresponds to 20 parts per million of gaseous contaminants, or grade N5.0 and higher. The nitrogen may be supplied by a cylinder, dewar, or a nitrogen generator, and should be regulated to 4 to 8 bar. The nitrogen supply connects through 6 mm diameter tubing at the rear of the spectrometer, where a regulator maintains a target pressure of 4 bar. From there, the nitrogen gas is guided through a filter, which ensures the nitrogen is clean and dry. Activated charcoal removes any trace of organic impurities from the nitrogen supply, which could otherwise deposit on the internal optical surfaces of the spectrometer, and a molecular sieve removes moisture. It is recommended that the filter be replaced whenever the lamp replacement is due. To do so, first switch off the pure gas supply and depressurize the nitrogen line. The filter is located behind the front panel. To gain access, first remove the lamp enclosure. Then remove the clip at the bottom left that locks the front panel. Now you can pull off the front panel. Disconnect the filter from the nitrogen line on both ends using a wrench. Finally, unscrew the 2 brackets that hold the filter in place. Now the filter can be removed and disposed of. To install a new filter, carry out these steps in reverse. After passing through the filter, the nitrogen enters a solenoid box which splits the flow into 3 lines to the lamp housing, monochromator, and sample chamber. Flow meters monitor the nitrogen flow rate for each line, which can be inspected in the Active Nitrogen Management System software. The current flow rates are displayed on the Monitor tab of the ANMS software. By default, the nitrogen flows at 1 liter per minute through the lamp housing and the sample chamber, and at 3 liters per minute through the monochromator. This makes a total flow rate of 5 liters per minute. Flow rates can be adjusted individually if required. Controls allow switching on and off nitrogen flow. The startup procedure can be initiated at the click of a button. The lamp ignite sequence will first remove oxygen quickly from the system at elevated flow rates, where a flow to each component is increased by 1 liter per minute. After 15 minutes, flow rates will be regulated to defaults, and after a further 5 minutes, the lamp will be ignited automatically. Most importantly, this startup procedure can be scheduled. Just enter the time of the day at which the lamp should ignite, choose the days of the week when this should happen, and confirm. Schedule lamp ignition about half an hour before you plan commencing measurements to give the lamp some time to stabilize. Once you have entered the lab, the system will be ready to go. Likewise, switching off a lamp and nitrogen flow can be scheduled. This means you don't have to wait and carry out a manual shutdown after the completion of longer experiments, such as temperature ramps. Schedules for both the startup and shutdown procedures are saved and stored in the controller and will be executed even if the software and the computer are shut down. Just make sure the lamp power supply remains switched on to allow for the automatic lamp ignition. The system includes an alarm system in the case the nitrogen flow is not sufficient. For example, due to nitrogen supply running out, an audible alarm will activate. The alarm will remain active for 10 minutes. If the cause of the reduced nitrogen flow cannot be resolved within this grace period, the lamp will shut off automatically. For more information including system manuals, visit photophysics.com.